Hello. Today we are back to subtracting fractions again. It's very similar to what you did yesterday. So we are still just subtracting the numerators. The denominators do not change. The only difference today is that you're going to see fractions that have larger numerators and denominators. Don't be fooled because you still know how to do this. For example, you may see something like this. 50 hundredths. Because believe it or not, things can be cut into 100 equal pieces and you can have 50 of them represented. Minus 20 hundredths equals. We can easily let the large denominators fool us, or we can remember that the denominator always stays the same. So it doesn't really matter how big the denominator is, how many equal parts there are, the denominator will still be the same. So right away, the denominator is 100. Now I just have to subtract my numerators. 50 minus 20. Well, I can do that work separately. 50 minus 20 equals, right? 0 minus 0 is 0. 5 minus 2 is 3. So my answer would be, the difference is 30 hundredths. So you see, it's the same exact procedure, no matter how large the numbers are. Let me show you another one. Let's say I have, can you see that? Let's say I have 60 hundredths minus 20 hundredths. My denominator is still going to be 100. Then 60 minus 20. 0 minus 0 is 0, and 6 minus 2 is 4. So I am left with 40 hundredths. There are a couple of word problems on there that may throw you for a loop with the wording of them. So I'm going to show you an example of one of those. Okay, let's say that I made a cake in a big pan. And I cut the cake into 12 equal parts. Those aren't really equal, but I'll do it again because I want to make sure that it's clear here. Okay. Okay. Not perfect, but better. Okay. So I cut it into 12 equal parts. Now, if you remember from yesterday, the way that we represent the whole in this case is the numerator and denominator match. It's the total number of parts, and the numerator matches that to show one whole. So in this case, it's 12 twelfths. That's the whole cake. Let's say that I serve 2 twelfths to my daughter, and I serve 3 twelfths to my son. How much cake is left over for me, right? So there's a couple of ways I could do this. With this drawing, I could count 1, 2, 3, 4, 5, 6, 7 twelfths are left over for me. The way that you might do this yourself is by saying, okay, if I have 2 twelfths for Olivia, and I have 1, 2, 3 twelfths for Nicholas, how many twelfths in all have they eaten? Well, they've eaten 2 plus 3, that's 5 twelfths. They've eaten 5 twelfths altogether. Then I might say to myself, all right, well, how much is left over for me? So I have to consider the whole is represented by 12 twelfths and subtract the portion that they ate. It makes it look like this. 12 twelfths minus the portion that the kids ate, which is 5/12, and I end up with 12 minus 5 is 7, and my denominator is still 12 because the total number of parts of the cake did not change. So you see, first I had to add up the portions that were represented that each person ate. Then I took that amount and subtracted it from a fraction that represented the whole. In this case, it was 12/12. If the cake was cut into 16 parts, it would have been 16/16. If it was 15 parts, it would have been 15/15. So you see, as long as the numerator and denominator match, that shows one whole, okay? So just so you know that when you go to do that today. And if you have any questions, please let us know.